Related rates continued. Now we're going to get into some geometric stuff. This first one is a classic. They love questions with cones. I don't know why. But these ones also involve two variables again. Okay, like you're going to have height and radius. And you can't solve for x and y at the same time. So you'll have to get a second formula and work that out and then substitute it in. Then take your derivative, okay? So, sure, okay. So, here's the example we're going to do. Cone-shaped drinking glass. I don't know why I just did my cup. Is being filled.
Cone-shaped drinking glass.
At a rate of 15 centimeters cubed per second. No, centimeters cubed. Talking about volume. Good. So that's my rate of change of the volume of the cup. Okay. The glass is 20 centimeters tall and has a radius of 4 centimeters. All right, at what rates? Is the water rising? When the depth of the water is
he?
9 centimeters. All right. All right. So we make a drawing of this. So it's a cylinder cup, so it's like one of those paper Dixie cup things you get at the water cooler.
That's pretty good.
I drew a lot of cones in universe. Lots of
Why are you doing that?
Did you recycle? Yeah, because remember I was bought. Didn't I teach you anything? Yeah, we went through, remember, like, what's recyclable, what's not recyclable?
I like how the video's still. Yeah, rinse it out because we have to sort it.
No, it goes in the blue bin, not the SAR can.
Oh.
The blue bin.
We take all the words to get the SAR can.
All right.
They were already mad at you, Leah. That's a bad idea.
So let's label what we have here. We know we have a cup. It has a height of 20 centimeters. Oh, that's just the line like that. My radius of the cup, what did I say, 4 centimeters? So that's my H, that's my R. Now we're filling this thing up with water. And we know the rate that we're filling the water or the cup up at, my dV dt, let's see, it was 15 centimeters cubed per second. Okay. Now, when the height of the water is at 9 centimeters, we are looking for the rate at which the water level is rising. So the water is rising, that is our height. We're looking for the rate of change of the height at this moment, at this exact second. Now, I know what you're thinking. When in my life will I ever have to figure out the rate of change of water in a cup? Never. Of course not. That's ridiculous. You have to appreciate that if we can figure out how fast the water levels is increasing by height, just think of what other things we could do with this beyond being shown this for the first time. Exactly, or that they're rising, or right, like all these different things. Anything that has a rate that changes or something, we can figure that out with calculus. Okay? So, now, we're dealing with volume of a cone. So if you look on your sheet, we know that the volume of a cone is 1/3.
How do we know this?
By our...
That sheet?
I gave you a sheet, silly.
I found sheets. So me.
What?
Now, you see here, we're looking for d of h, right?
Yeah.
We have two variables in the question, r and h, right? Do we normally solve questions with two variables? Always.
But never.
Never. No, we always substitute one in for the other, right? If we're solving for dh, which one do you think we want to keep? H or r? H, right? So we got to get rid of r. So what we do is we set up a little ratio to do that. All right? And it's our height. So get rid of r. So we're going to check ratio to height, okay? That's our ratio is going to be radius to height. Sorry, not ratio. Okay? So we know our radius is what on this cone?
4 centimeters.
4. Good. And the height is
20 centimeters.
20 centimeters.
Which is equal to 5.
1/5, right?
Yes.
Yes. So our ratio is 1/5. Okay. Now we are trying to get rid of r.
Yes.
So we bring, so we know r to h, I'm just rewriting this as 1/5. If I brought h over to the other side by multiplying, I know that r equals 1/5 h. Does that make sense? You wouldn't have known to do this, but this is what you do. Okay, this is the tricky part, and this is why they like to ask the question. Okay. Bingo. Bingo. Okay. See how that's starting to make a little more sense after when I showed it in optimization, you guys were like, no, that's voodoo. I'm sorry, that doesn't know. But now it kind of, okay, I gotcha. Or another way you could write this, I just put h on God.
Okay.
1 times h is h. Yeah, it just tidies it up a little bit. So now I'll plug this in for r, so I'm going to have v equals 1/3.
Pi. Well,
Oh, it's pi. 1/3. Yeah, I know I was going to say, and I won't forget the squared this time. So it's going to be h/5 squared times h again. So we can clean this up. I'll show a couple steps here. I'm going to put it 5 over 3. H squared is h squared. 5 squared is
25.
times h. Now, real quick, what's h squared times h?
H cubed.
Okay. And what's 3 times 25?
75.
Boom. There's our formula.
That kind of made sense.
Good.
Just add it. Put it in.
Yeah.
Just pull your anger dude.
That's what I've always loved about this stuff is how you can make it a really nice formula to work with. Okay. Now we just take the derivative. Okay. Of this. So the derivative of v is just 1, right? But it's going to be dv dt. No, you don't have to. I wasn't gonna, but I thought I probably should. Because someone's gonna be like, what? Now, derivative of this guy, I bring the 3 down, so it's gonna be 3 pi over 75 h squared.
Is the h like the whole thing or just to the top?
To the whole thing.
Okay.
Yeah. So this is actually, just bring this over here. dv to dt. 3 over 75 is just 1 over 25. H squared. Oh, don't forget dh to dt. Classic Weber again. dt. That's the rate of change. That's the change of height over time.
We did that because we took the derivative of h?
Yeah.
Okay.
And then, like, I took the derivative of v, so I had to put dv over dt. All right. And it's always over t. All right. Cool, man. So back to the original question. What were we trying to do? Well, we wanted to find dh of dt. Let me finish this one up. When my height's 9 centimeters and my rate of change with the volume is 15 centimeters. So let's plug in those values. So dv over dt is 15. Cool. Pi over 25 is just pi over 25. The height was 9. And I'm looking for dh over dt. Do you have a quick question or do you need me to come over there? Do questions 1 to 4.
No, I don't. You gave me a bit of chocolate.
Well, I'll be right there. Let me finish this up. I want to roll. So this is now 15. 9 squared is 81.
It's too old.
All right. Now, let's solve this like they would in university without a calculator. So first, I gotta get dh dt by itself. So I'm gonna multiply 25 over to the other side, right?
Yeah.
All right. So let's do that. 25 times 15. Right?
Sure.
We all remember how to multiply?
No.
Not really.
I know it's a lost skill. That's why I decided to show it. 5 times 5, 5 times 10.
Wait.
Carry the 2. 5 times 5 is 25. So
Yeah.
bring 5 down, carry the 2.
Yeah.
5 times 2 is
10.
plus 2.
12.
Right. Put a 0 down because I'm at the hundreds now, so I put a 0. 1 times 5 is
5.
and 1 times 2 is 2. And then you add up your rows.
Okay.
Because remember, this represents the tens column,
Yeah.
so you got to put a 0 there. right? We remember that.
No, I'm gonna have to
Yeah,
go
when we got
like.
it really, really wrong. Maybe that's why.
Okay.
If you, this works. Trust me. Ask your mom. Maybe she knows another way of teaching it now. It's all drawing pictures with squares. I don't know. I don't understand
That's
it.
all they do is draw pictures down.
I don't get it.
Or I can just draw all
This is
of them.
recording. It's official. That's going on YouTube.
I can just draw the 375 boxes.
Yeah, Carson's gonna draw out 25 boxes and multiply.
Please do that on the side of your test, just like,
So-
like
And then count them all out one by one.
One.
Okay, now we're gonna bring the 81 pi over. Oh, that's 375. You can't do anything with the pi unless you have a calculator. I can divide probably a 3 out of everything. 75 divided by 3. Right? 300 divided by 3 is 100.
Yeah.
81 is a multiple of 9, so it definitely can be divided by 3.
3 times
7.
27.
Yeah.
I can't believe I got that.
Now you could raise a decimal. This would be one of the answers on the multiple choice test on the math test, though. Oh, units. Change in height to time. So that should be centimeters per second.
Yeah, first.
By changing height. No, this is just the units,
Oh,
right? I'm not dealing with area. I'm not changing the rate of the area. This isn't dA or dV. Okay. Typically, you'll always be given the dV or dA of the question, and you need to find one of the units. So it's just regular centimeters per second, whatever. How does that sit?
Not too bad.
The only weird thing that I thought might have been a little iffy was this part here,
yeah, how do you know what to do?
because I showed you how.
Okay.
That's it.
Like we do that for every column?
Yeah, and you have to set it up so you know which one you're looking for, right? Like if we were looking for the change in the radius, we would have got h over, we would have had solved for h. And you would have put h over r instead and then had 5 over 1.
So that'll be like a plus. That'll be a bonus question on the
Yeah.
on a midterm.
Yes.
number two.
Okay. So I'm going to give you guys a couple of these to try. Some of the triangle ones, and then some of the non-triangle ones. The non-triangle ones I'll keep. So I'll find the easier ones. I don't mean to sound like facetious there, but.
You should pause the recording.
I'll put the assignment down. So on page 284.
Get my hair. I'm sleeping. I hate to do it. It's like, it's
1 7 on. We won't do the swimming pool one. Now the ball ones that I'm going to give you are really, the spheres are really nice because area of a sphere is, what is it? Oh, sorry, so right, so it's all volume stuff. Yeah, the volume of a sphere, sorry. This is 4/3. So is it pi r cubed?
Yeah.
So is there like any extra variables you gotta find, like get rid of?
Oh, no.
No, so you just
You solve.
abracadabra. Yeah, you take the derivative and go. Okay. So on page 290.
For Wednesday.
What is this? Is this the same time?
Yeah. With 6 to 12, even. Okay. Now this is it for like time that I'm going to give for this though too. So you have to do this stuff.
I'm gonna be pounding out math questions all weekend.
Yeah, you have to. When I took this stuff in first year uni, the guy walked in, he did the ladder question, he did a cone question, and then we moved on. Okay, so, and then you went to the math help center. I don't know what I'm doing, and then you did hundreds of them to figure them out. Ooh, don't let